Today's lesson 6.4 is solving special systems, and we have actually talked about special systems before. Those are the ones that either have no solution, and remember those lines are parallel, or there is infinitely many solutions, and those lines are the same when you graph them. Now on this page we're just reminded of what we did yesterday actually. Here's a system, and in order to solve that system by elimination, we had to multiply the top and bottom equations, and one possible number you could multiply by the top is 5, and then in the bottom we would multiply by 2, and that would give us this new system. But then watch what happens in this one. When you add to cancel out these opposite coefficients, then you add the middle terms and they actually cancel out as well. And when you add the last terms, the constants, they cancel out and you get 0. And so we end up with this equation where both variables have been canceled and 0 equals 0. So it's a true statement. And when it's a true statement, what happens when we graph it is the lines are the same. So if we actually put each of these equations into slope-intercept form, they would be the exact same. They would have the same slope, they would have the same y-intercept, and they would be the same line. Therefore, this is an example of an equation that has infinitely many solutions. And you can see here on this page how they looked once I solved them. Each equation for y, I got them into slope-intercept form, and then used their slope and their y-intercepts, which are the same, to graph them. The red line, which is the bottom equation, and the blue line, which is the top equation, end up graphing the exact same line. Therefore, again, there are infinitely many solutions. And this will be a good reference page for you to remember that when you graph and you have different slopes, or if you just notice in an equation that there are different slopes, then automatically there's going to be exactly one solution. If in your equation, or if when you graph, they're the same slope and the same y-intercept, then there are infinitely many solutions, like the one we just went over. And then if you graph, or if you just realize from the equations that the slope is the same, but the y-intercepts are different, then they are parallel lines, which will never cross, and therefore there are no solutions. So how do you know, just by looking at equations, what type of an answer you're going to get? If you're actually going to be able to solve it and get a solution, or if it's going to be no solution or infinitely many solutions. There's two different methods. The first one is that we just compare their slopes and y-intercepts. The slope of the first equation is 1. The y-intercept is -4. And I know that because it's just in slope-intercept form for us already. The bottom equation, we would need to get into slope-intercept form. Once we do, we know that the slope is 1 and the y-intercept is 3. So the slopes are the same, the y-intercepts are different, which results in parallel lines. So there are no solutions. Solving the exact same system, but this time solving it what we call algebraically, you're just going to start solving the system like normal. So maybe you choose to use if I look at this system, I would say it's set up pretty nicely to use substitution, where I can take what y equals and put it in place of y in the other equation. So that makes our new equation negative x plus x minus 4 equals 3. When you combine your x's, they cancel each other out. Negative 1x plus 1x is 0. And what we're left with is negative 4 equals 3, which is not a true statement. False statements result in no solution as your answer. So without graphing it and without even comparing slopes and y-intercepts, if you just started solving it like normal, this is what would happen. Your x's or your y's, or both, would completely cancel out, and we'd end up with this false statement. And then automatically your answer is no solution. Why don't you try this one on a piece of paper and press pause and come back and see how you did. And here's the answer for you, no matter which way you solved it, whether you chose to just compare slopes and y-intercepts, or whether you solved it algebraically, your answer should be no solution. Here's another example, and I'll just solve this one algebraically to begin with. And let's see, then we would probably want to replace 3x plus 2 in for y in the bottom equation. Obviously, you could also use elimination at this point, if that's what you prefer. But I've basically rewritten the bottom equation, 3x minus, replaced y with 3x plus 2. Be careful to replace it in parentheses. And then here's the plus 2 equals 0. And then just solve it from here. So distribute. And again, our x's combine. 3x minus 3x is 0x. And negative 2 plus 2 is 0. 0 times anything, 0 times x is 0. So we end up with a true statement. 0 equals 0. And like we had kind of talked about in the very first example, a true statement equals infinitely many solutions for your answer. This is the algebraic way of solving it. Obviously, we could also just compare slopes and y-intercepts. The top equation has a slope of 3 and a y-intercept of 2. And the bottom equation would need to be transformed into slope-intercept form before we can find any of that. Don't forget to divide by -1. And there's our equation in slope-intercept form, which you might notice is the exact same as the top equation. And their slopes are the same. Their y-intercepts are also the same. So we give the same answer, infinitely many solutions. They're the exact same equation. Part of your homework today will say to give the number of solutions. So your answers are either going to be 1, no solution, none, or infinitely many. And probably the easiest way for you to determine that is to just compare slopes and y-intercepts and see if they're the same. or if they're different. And by the way, if there's just one solution, you don't actually need to solve it and say what that one solution is. You can just say that there's one. So let's get all of these equations into slope-intercept form, because that makes it easier to compare their slopes and their y-intercepts. So the first one has different slopes, 4 and 1, has different y-intercepts, 4 and 3, so there's one solution. And again, you don't need to say what that one solution is, but these two lines would cross at one point of intersection. And then let's see, we would take away x on the top. And there's that equation. And for the bottom one, we would take away 4. And then in this example, we have slopes that are the same, they're both -1, and y-intercepts that are different. So this time we have parallel lines. So we have no solution.